Hello, and welcome to my talk, Componentizing Application State. My name is Nick Nisi, and I'm a staff engineer at C2FO, the organizer and MC of the former Nebraska JavaScript Conference, MC of TypeScript US, and a panelist on the JS Party podcast. I also really like JavaScript and TypeScript, and React is pretty cool too. So I'm here to tell you today that your application state is too complex. Now, of course, there are lots of different ways that you can do application state, or as a phrase that I learned in college doing Perl, Timmy Toady, there's more than one way to do it. And we're going to explore some of those different ways, and I'm going to try and convince you of a pretty good way, in my opinion, of organizing your application state. We're going to look at an application called the Quiz Show, or on JS Party, what we call JS Danger, which is a Jeopardy-style game show that we play with our panelists and guests, and it's a really fun time. In this screenshot, we had the CSS Tricks edition, where we had Chris Coyer, Sarah Drasner, Jeff Graham, and Miriam Suzanne on to play, and it was a lot of fun. Now, the site was originally built with Dojo and uses Dojo stores. That's modern Dojo, and so it looks quite a bit like React, but let's go ahead and convert it to React, and we'll set up a new flow for the application state. So what should we use with React? To manage the state, we could just do, the context way, where we just define an object, keep it in a React context, and then access it through the use context hook and a provider. And that's a good idea, but it lacks any real structure for dealing with the state object and how we might change it. Another way that we could do this is with Redux. So we could create a reducer and, add a little more structure around how we actually make changes to the state by dispatching these events to it, and then having the reducer run and make changes to the state object and return a new state object for each instance. And that is a good way to do it. And there's lots of tools built up around Redux to make it a really nice and viable option. There are some drawbacks to it though. So while it is good structure, there's still a lot of ways that you can potentially hurt yourself. There's things like infinite states or impossible states. It can be really hard to visualize and understand everything that's going into the state of the object and how things are changed. And that just exponentially grows as the app gets bigger. Now, of course, like I said, there are a lot of frameworks and tools that can help make this easier. I'm not here to drag Redux or anything like that. I think that it's a great project, but we're going to look at another way to do that, and that is with something called XState. Now, XState lets you create a set of finite states in what they call a state machine, and those finite states represent just the finite areas of state that you can be in, or the state values that you can be in. And then, of course, you can have more infinite states, and those would be handled through its context or its way of storing data that would be infinite in scale. So if you think back to our Jeopardy-style game machine, the number of questions could be infinite. So that can be stored in the context, and then we can have a machine to move through the different views of how we want to look at those different states. And the other nice thing is you just define everything in this object, and side effects are declarative and explicit. So you can say, when you're in a specific state, these are the specific actions that I can run on that state and nothing else. Some other benefits is it's framework agnostic, so you can take it anywhere. We don't have to convert this app from Dojo to React, but we will. And we just can create this declarative configuration that's really easy to follow along as you're coding it, but we'll see some other benefits to that as well. So when we're working with it, we define these transitions that work in very specific states only, and then those state machines can also invoke and send messages to other state machines. So we can break up our large application state into smaller machines that can handle those small pieces and then send messages back and forth to pass that state up or down the tree as we need to. We can break it up as it makes sense for us. So let's talk about React components for a second. One really nice thing about React is that it just makes it really easy for us to use declarative UIs and generate our code declaratively through JSX and then return that. So we can kind of create these pure functions that take in some parameters and then they output some markup, and that's what we want to use. So in this case, we have like a game, and the game can render players, and the players just renders out the player's image and their name, things like that. And working with those declarative UIs is really easy and fast and fun. And it lets us work with those components as if they were just pure functions with simple inputs and outputs. And of course, we can add complexity to that. We can add complexity to anything. So we'll build out, now when we're building these, another cool thing is that we can build out the components on their own, or we can build them up as part of our application. And, obviously that is where we want to test everything as part of the application, but we can also build out a test harness page to test the components in isolation by themselves without needing to render the entire app, especially if we keep them pure and just have specific props that we can pass in and just expect the output to be in a specific way. We can write tests and create a harness page to do that. Now, one simple way of creating a test harness or a UI harness page to look at those is through a tool like Storybook. Now, Storybook is just a tool that you can use to build components a bit faster. You can build those components outside of your app, so you don't have to spin up the entire app. You can set up the component in the exact state that you want, and then visually view it and test it, and have others, like your design team, sign off on whether or not the component looks correct or not. So you get to control the data that's passed into it and how they're rendered. And it really is instrumental in streamlining development and testing. Now here's a simple fuzzy GIF showing an example of rendering the contestant component for our game. And we can just create that component, render it out there, and we even have controls to where we can change the inputs on the fly and see how it reacts to things. So what if we could do this with our application state? That would be really cool. We consider an example like this. This is a Miro board that defines some really complex state. When you get to a page, we want to render in a specific way based on certain criteria. And then from there, render based on more criteria and user selection and different events occurring. And we can see that we can build up some pretty complex flows for an application. Now, what if we could componentize that application state and the way that that works in a nice, easy way that was automatically kept up to date with our code, rather than having to separately maintain a Miro board and the code and just make sure that any changes from one automatically get reflected into the other? What if we could do that? That's the goal of what we're trying to do here when I say componentizing application state. That would allow us to treat the application state as if it were just any other component, where we can work on it completely independent of any UI, and we can get it completed before the UI exists, even if we wanted to. And we can walk through that flow with our non-technical stakeholders and make sure that it is up to date and reflects the actual requirements that we have for the application and its flow. Well, XState can do all of this. Through that state machine that you build, XState can render state charts directly from that, and then you can use that to walk through the application and use that as a visual way to depict what is actually happening in the application without having to rely on a separate third-party tool that has to be manually kept up to date. It also allows you to walk through that state and verify all possible routes from one state to another, and you define those explicitly. So there's only a finite number of ways that you can transition from one state to another. And you can test all of that and visually view that all of that is correct. So that makes walkthroughs easier with product teams and other stakeholders. And this is something that you can do all inside of Storybook. There is a plugin for Storybook called Storybook XState Add-on that you can add to it, and it will allow you to do just this. So to give some context around the app that we're converting to React and XState, this is it. It's a Jeopardy-style game show where it has a list of contestants, and the contestants can have their scores changed, plus or minus. It also has a game board that has different categories for each round, and then each category has a list of 5 questions worth 1 through 500 points each. And when you click on a question, it pops up with the question itself, and then it has a show answer button, and it will show you the answer. And then depending on whether they got it right, you can click that and it will automatically append the correct point value for the question if they correctly answered it. Then closing the question will blank out that question, so it can't be asked or looked at. It can't be assigned points again. So let's take a look at how we could create a state machine that can run this game in the way that we want it to. So first off, we're going to create the Storybook story that can render this machine. Now we'll create a game machine next, but we'll import that and we'll just create a new story called Game Machine that will use this render machine component from the Storybook XState add-on. And we'll just pass in the game machine that we want and we'll be able to render it from there. So let's go define that game machine. We'll create a game machine TypeScript file. We'll open it up and we will export a game machine, and we'll use the create machine helper from XState to create that. We can give it an ID of game machine, and we will also give it a list of states. So if we do that, well, first let's just refresh and see if it creates it here. So in XState, we now have this state chart diagram being rendered for us, and we haven't defined anything, so there's nothing there yet, but we'll fill it out as we go. And the state machine has a context, which currently is empty, and it has an event that was used to initialize it. And then, yeah, so let's continue on. And now looking at the game has a couple of different views that we might want to signify as states. We have this kind of like idle view, which would just be like our main game view itself, where we're just displaying the board with the different questions that we have, and we're also displaying our contestants along the right. And so we can define a game state here. And then we can also nest states as well. So if we just create the game state first off and take a look at what that'll look like, it just creates a little box for the game state. And then we'll create a initial state within here called idle. So this is just the idle part of the game when we want to show the board. So we'll call it idle like that. And so the game exists like there with an idle state. Another state that we'll want to show is a question state. And this would be when we actually select a question that we want to view. So we can just create another one in here called question. And now we have a game state, an idle state, and a question state, just like that. Nice and easy to read in the code, and also easy to look at and view on the actual state machine as well. But the question state has a couple of different states in it as well. So if we think about this is the idle state. Here would be the question state when we're actually showing the question, and then we also have a show the answer state. So we can add another nested state here, and in here we'll call it answer, or we'll call it show answer, like that. Okay, so now we have these states defined. Another state that we might want to define outside of the game state is a winner state. And this we will signify as a final state, meaning that the state machine is done when we get to this state. So it draws it with two outlines like so, and that would signify and trigger an on-done event if we define one. But it basically means the state machine is over and it will stop listening for events once it gets to that state. So now that we have these states defined, one thing that we'll want to do is define the transitions that can happen between the states, or explicitly define how you get from one state to the next. And when we define these are the only ways that you can make those transitions. You can't skip any steps, which is one of the big benefits of XState, is you explicitly define everything that you have, every transition that you have, and you can't deviate from that. So it is a finite number of steps to get from one state to another, and you completely control that, and you can see it in the diagram, the state chart, as we're rendering it. So we'll start from the idle state, which is, again, is where we're just viewing the game board. And from here, we'll say anytime an event comes in called select question, well, we want to target the question state. So when we re-render that, we will now go to the question state. And inside of question, we'll have two different states in here. We'll add a default state, which is just show the question, and then we'll have the show answer as well. And we'll make the default that we go to, or the initial state that we go to, be default. So once we select a question, we will go straight into it from there. We'll also define our initial state as game up here, just to get it going. And now we're in the idle state, we're in game state, we're in the idle state, and when we select a question, it will go to the question and it'll immediately go to the initial state for that question, which is default. So then when we're in the default, we will want to be able to toggle between showing the answer and not showing the answer. And so when we're in the default state, we can add another on block here, and we can say on toggle answer. And from here, we'll go to show answer. So when this re-renders, we can select the question, and then we can toggle the answer. Now from show answer, there's nothing we can do. If we select toggle answer, nothing happens. But we could define toggle answer here again, and this time say that when we're in show answer, go back to default. And so now we have this loop that we can do. We can go select a question, we can toggle the answer, and then we can come back to our default. And then while we're in the question, anywhere in the question, we want to be able to close that. So we can actually define this on the question itself, and we can say on, and we'll say close question. And the target will be to go back to idle. Oops. There we go. Okay. So now we can select a question, and then we can toggle the answer, show it, and then we can go back to idle. And then from anywhere within the game, we'll want to be able to select a winner. So we can say on, and we can say set winner, and we can target winner. If we're only targeting, we can do a shorthand syntax like that, where we just give it the name rather than an object and a target. But now we can say from anywhere within the game, set the winner, and we'll go straight to the winner state and show it right there. To save some time, I have populated the game machine, and I have added more type safety. So I defined an interface to define the context that we have. Now the context is where we can store things that might result in infinite states. So for example, in our game, we have a infinite list of contestants. We could have one to many contestants, and we have a list of rounds, and each round has a list of categories, and inside of those categories is a list of questions. And so there is where our infinite states can come in. We wouldn't want to define a finite state in the machine for each state of that. So now the coolest part of this is that we have the entire state of our application fully complete, and we can test it, and we can actually visualize this. And we can visualize this with non-technical stakeholders and show them all of the complex interactions that can happen throughout the game. And no other interactions can happen. All of this is completely set in stone in the way that we have coded it. And this state chart is derived from the actual code that manages the state. And so it's always kept up to date, and it's always easy to walk through with them. And you can see right here, we haven't even created any UI yet, and we can step through and make sure that everything is correct. And that, you know, for example, you can get into, you can select a question, you can show the answer, and you can clear the board and continue on to new rounds and set a winner, all before we even have a game board designed or anything. So to actually use the state machine from React, something that we'll want to do is to create an instance of it by interpreting it. And XState React comes with a handy hook to do that called useInterpret, where we can just pass in the game machine that we defined and some options to it if we want to. In this case, I'm turning on DevTools. And then we get back this service. And so a nice place to put that would just be into a ordinary React context. So we can create a game context and set that, and then set the provider for that so that we can access it anywhere from within the children. So then from there, we can create a couple of hooks to be able to actually access that data. So the first hook is a use game service hook. And what this does is it would grab that game context off of the provider, and then it would just do a check to make sure that we're actually inside of there and throw an error if not. That way we know for sure that the service is actually defined off of the context and we can return it right there. Then the next hook that we could create from there to kind of simplify grabbing things is this use game selector, which is just a wrapper around a use selector hook that XState comes with, which allows us to pass in the state and then provide a selector, which is just a callback that gets the state and then can return some value from that state that we can then work with. And so that could be things like the state's value, like what state we're actually in, whether it's game or idle or winner, or it could be the context. It could be state.context, and we could grab data off of that. And that is probably one of the more common ones. So we can create another helper called use context value, which will just take a key from the context and it will just call use game selector and provide back the value from the context itself. So these are some helper hooks that we can set up to quickly and safely grab that data in a nice way using some of the built-in hooks that XState provides to us. And so from there, we can define a couple of other hooks, one to get the status, specifically whether or not we're actually in the game or whether we're loading the game. And then we can use one to get the data that we need for the game. So that's things like the contestants or the currently selected contestant or the current question or the round that we're in, things like that. And so we can grab all of these from the context, and the way that this is set up using that the use selector is that all of these will update as they change. Anytime that the state's value changes, these will get updated, which will trigger a re-render so that our UI is kept up to date with all of the latest values from the state machine. And then we can derive a couple of other values like the current round that we're in and the number of rounds that we have. And we can even define some handy callback helpers like this one, this set round, which is just a callback function that will grab either the next round or the previous round, depending on what we send to it. And then it will update the round by calling the service's send method to send a set round event to it, which will set the round to the one that we set it to. And so that's a way that we can like automate a way of, or simplify a way of communicating with the machine, is by creating some handy reusable callbacks that we can use from anywhere. And so then we can return all of this from that hook and then be able to use it within our application anywhere. And there's lots of other hooks that we can do, to make things a little simpler for us. This one, use question, for example, grabs the current question and provides a callback to select a question. And so from there, it provides an easy way for us to show answers, toggle the answer, close the question, really do anything that we need to actually work with a question or get us into the right state to see that question. And so then from our actual application, the app.tsx can do some pretty easy and simple things just by calling these hooks. So we can get the game data from here and get all of the values that we need to render, see whether or not we're in a loading state, if we're waiting for that data to come back, or if we can just render the game automatically. And from there we can define, if If we have a winner selected, we will show that winner. Otherwise, if the view that we're in is contestants, meaning that contestants state, well, we just want to render a list of the contestants and that's it. But if we're not in either of those views, then we'll just default to the idle view, which is the idle state defined in our machine. And from there, we'll render out the current round that we're in and our list of players, which gives us the exact view that we want. And so this is how we can actually take that data and look at it, use it, and react to it from our React code. So all in all, pretty handy and pretty simple to set up. And so if we dig into this a little bit more, we can see that, for example, in our players, let's go dig into players, and the players component just renders a list of players. And if we go look into there, we can see that there is a use player hook that's being called to get an increment and a decrement value. Let's go look at that real quick. And increment and decrement are just callbacks that are sending a increment score or a decrement score event to the machine for the currently selected player. And it's either, if we pass in a value, it's doing that for that value. Otherwise, the current questions value, if we have a current question. Otherwise, it just defaults to 100 for each of these. And so that is how our players are rendered. And then we can just take the increment and the decrement and hook those up to buttons so that when we click on those buttons, increment and decrement are what's called, which triggers the machine to actually react to that and update. So nice and easy way to send events from our React code directly into the machine itself. So when we take a look at what this looks like, let's bring back up Firefox and we'll go over to the actual fully running app. And so this is the app rebuilt from Dojo over to React using XState. And I've rendered the XState viewer down below just to show what it looks like as we're moving through it. So when you actually have it set up like this, a really cool thing that you can do is as you're navigating through the game, you can see what's happening in the state machine in real time. And so the game has been loaded. We are already in the game state. We're in the idle state, and the actions that we can do from here are toggle the contestants. So we could view a contestant's view like that or not. And we can select a question, and select a question is what will get triggered if we select a question like here, for example. And so in here, you can see that we're actually in the question default. And from here, we can set the current contestant or we can toggle an answer. And so if we can click it on the state machine too. If I say toggle answer, it will show the answer. So the UI updated to match the state. And one thing that we can do from anywhere in here is increment score or decrement score. So I can select any of the players here. I'll select Sarah and increment the score. And it incremented by 300, which was the value for the question. And then when we click on the question again, we go back to the idle state and the question itself has been updated to be marked as used so that it won't be rendered anymore. And we can continue on to a different question. So that is how we can use XState and React to render a very simple Jeopardy style quiz show. So that is how you can use XState to treat your application state as just another component and work on it independent of any other UI and get stakeholder buy-in before that UI is complete. I hope you check it out. Here's some links for you. XState's website. There's a link to the quiz show and also a link to the Storybook add-on so that you can get this set up in your project today. Yeah. So I just want to say thank you very much, and I will see you next time.